and welcome to Alicat Chat. My name is Cesar Spinelli, and today I'm joined with Bobby Singh from Kaizen Controls and Automation. How you doing, Bobby?
I'm doing great. Thanks for having me here.
So, Bobby, we're really interested in learning more about the oil and gas industry. Could you tell us a bit about your professional background?
Yes, I've been in the heavy industrial sector, which is upstream, midstream, downstream, for about 20 years now. I started working with a rep firm when I got out of college, uh, basically selling instrumentation, analyzers, mechanical devices. That's where I really learned the industrial sector and the different processes. So I left the rep firm and started working with Emerson, selling their micromotion and Coriolis meters and Rosemount, Mag, and Vortex. So I got a great handle on flow and the different technologies, the disadvantages and advantages. After Emerson, I joined Alicat Process Instruments, mostly dealing with mass spectrometers, tunable diode lasers, basically process analyzers. Then COVID hit, and decided to break off on my own and started Kaizen Controls and Automation in 2021.
So, you've been in the industry for a while. Could you tell us a bit about the changes you've seen over time?
Yes, the oil and gas industry. When I joined the industry, working for the industry, oil and gas was mostly being imported from OPEC countries. So basically, we had LNG facilities set up to bring in LNG. We heat it up and put it in the pipeline. Well, fracking came along around 2009, 2010, and that totally changed the oil and gas industry. Rather than importing oil and gas, we had to re-engineer those facilities that were designed to import natural gas to export natural gas. And it really changed the dynamics of being energy independent, the geopolitical environment when it comes to energy, and which is usually the most important topic when it comes to a country's self-defense.
Because of this change, has there been any shift in measurement and control challenges in the industry?
Yes, there's been a big change when it comes to environmental rules and regulations. It basically, what we're trying to do, what the government's trying to do, is reduce fugitive emissions coming from the oil and gas industry. It remained pretty much unchecked up until recently. It went from a declining industry to a booming industry. And so you have a lot of the oil wells up in the Bakken, which is North Dakota, Eagleford, which is New Mexico, Texas, and also in Louisiana, and also different parts of some parts of Colorado and the Atlantic East. And so the biggest challenges are they're called super emitters. These are oil and gas facilities that release large amounts of methane, whether it's due to not flaring properly, not venting properly, or not having the tools and equipment in place to prevent those fugitive emissions escaping into the ambient air. And so we're seeing a big change right now. It actually depends on the administration, which guides the EPA. And so right now, there's been a slight pause on enforcing some of those rules and regulations when it comes to fugitive emissions.
So, Companies during their downtime look at new technologies that are emerging, and then they decide what to do with them in the future. Could you tell me a bit about digitally, intrinsically safe solutions and whether or not those have been on the rise?
So, since we have a lot of fugitive emissions, that means you have methane gas that's constantly present in or around process equipment. And that makes the area a class 1 div 1 area. And there's two ways to approach class 1 div 1 area when it comes to instrumentation and analyzers. One is you can get an explosion proof instrument, which is bulky. It's hard to work on. It may contain 18 bolts. It's very heavy, takes up a lot of space, and it's really a pain to work on because the instrument must contain the explosion. And that's what explosion proof means. And so you may have an instrument or an analyzer that has this 60-pound door on it with 18 bolts when it's installed, and the time after it's been in the field for a year or two, you go look at the analyzer instrument, it still has the door, but now it has like 2 bolts. And so it just takes a lot of time to undo the bolts and put them back on. Now, once you remove the door, now it's no longer explosion proof. They have to power it down. Now, with being intrinsically safe instrumentation, you don't have to worry about, a big bulky enclosure taking up a lot of space. You can work on it while it's still on and reading. And that's one of the biggest advantages of using intrinsically safe instrumentation and analyzers, is that the fact that it doesn't take up as much space, it's not as bulky, and it's easier to work on.
Having met some of these technicians out in the fields, what makes their lives easier?
What makes their lives easier would be not having to constantly work on equipment. So you have a technician, and just imagine a technician in a truck with tools, and he doesn't have a maintenance shop. His maintenance shop is his truck. And this technician is covering an area that's 30 to 45 square miles, which may have 7 or 8 different drilling rigs. So their time is limited. If there's an issue, they have to go back and physically check the analyzer or instrumentation. So they run very lean. So what they're looking for is technologies that are low maintenance and easy to work on. And we're starting to see a change in where companies are starting to use more modular systems when it comes to analyzer systems and instrumentation.
Is there a reason that the oil and gas field is slow to adopt new technology? And what do you think stops them from adopting this digital approach?
I believe that people, by just human nature, don't like change. If they're familiar with working on some piece of equipment, or if they're just familiar with the technology, people just are less susceptible to change, and it has to come up from a corporate down initiative, or a OSHA incident, or something that's guided by the government, like I said, just like OSHA or the EPA. Those type of rules force change, as well as having new technology that you present to corporate engineers. And that's the best way to make change happen, is having a top-down approach when it comes to new technology. And even then, they have these legacy products that always worked, and if they don't feel pain in their mind or their eyes, then there's no change.
Can you think of a time where they've used this older technology and supported it with new tech?
Yeah, so let me give you another example. So we have an analyzer that the higher the pressure, the better the lower detection limit is. So it can go up to 50 pounds. That's the max pressure rating for the analyzer. For every pound you get close to 50, you increase the accuracy by 2 ppm. And the customer needed, he scales 0 to 10 ppm. So they had a dome regulator on the upstream side of the analyzer set to 48 pounds. But due to pressure, due to just the technology that a traditional regulator has, it would overshoot, hit 53 pounds, and cause the analyzer to go into alarm. So what they did was they bought an Alicat pressure controller. They set the pressure to 49.99999999 pounds. Yeah. So the pressure, it hasn't gone to fault. He's getting the accuracy. He's operating close as he can to 50 pounds. And so he's getting the reliability. He's getting the best out of the analyzer. The key thing is analyzer reliability. Because if you don't have the right pressure or the right flow, you don't have the analyzer needs certain requirements. If you don't have those requirements, whether it's pressure or pressure, the amount of flow that's going through the analyzer, or let's say if you're returning the analyzer sample to a vent or to a header or to a flare, let's say at a flare, it's, at 2 pounds, right? But when the incoming sample gas is at 15 pounds, the flare goes off, well, then you have 10 pounds of back pressure pushing it back. Sometimes you have a reverse flow because the return point starts to have a pressure spike. And so then we need back pressure regulators too. And so what customers like about the Alicat, that it controls the back pressure while it shows you the flow rate. And so having a multivariable device that does pressure, that does temperature, that does flow, has a control valve, that's 4 instruments that typically, nobody has a flow controller that's IS. So if they need to measure pressure, temperature, that's 3 instruments right there. The Alicat, that's all in one. So they can get the flow rate, they can control the pressure, they can output the temperature and pressure to the analyzer for compensation off that one device, rather than having multiple IOs. And that's where we start to see the advantage is data collection. What are they doing with that data? Not quite sure, but it's going to be used for the digital transformation. They're going to use AI to determine, if the ambient temperature changes, if the storm comes through, we know that processes change, even from ambient temperature changes. And so they'll know how to control automatically and tune the loop to optimize the process based on certain conditions, depending on where those conditions are, what's causing those changes. But data collection is important in order to move to that next transformation.